All right, let's dive right in. This is going to be a purely technical reference for entity relationship diagram syntax. We're going to break down exactly how to read and build these diagrams, focusing only on the components and their notation. Let's get started.
So here's our plan. We'll start with the concept of a data model, just to set the foundation. Then we'll build up our ERD, piece by piece, starting with entities and their attributes. After that, we'll see how to connect them using relationships and define the rules with cardinality. And finally, we'll bring it all together and analyze a complete real-world diagram.
Okay, section 1. Before we can even start drawing an ERD, we've got to understand what it is we're actually modeling. And that brings us to the foundation of it all, the data model.
So what is a data model? Well, you can think of it as the blueprint for our data. It's the formal description of all the information a system needs to work with. The really key thing to grasp here is that it defines a static structure. This isn't about how data moves or gets processed, it's about how it's organized and related when it's just sitting there.
This diagram here really lays out the whole workflow. See, on the left, we start with our conceptual data model. That model is then used to generate the database schema. The actual tables and columns in the database. And then that schema gets accessed by running processes, which could be kicked off by a user or maybe another system. It's a clear path from an abstract idea to a practical, working application.
Okay, now let's get into the actual building blocks of the ERD itself. We're going to start with the two most fundamental components, entities and attributes. The easiest way to think of an entity is just as a noun. It's any distinct person, thing, concept, anything that the system needs to store information about. These are the main subjects of our data model.
In standard ERD notation, we draw entities as rectangles. It's that simple. So in this example, you can see student, lecture, and teacher are our entities. They're the core nouns that this system needs to track.
So if entities are the nouns, then attributes are kind of like the adjectives. They're the specific properties or details we need to store about each entity. And here's a key rule. A given attribute can only describe one single entity.
Here's how attributes look in what's called Chen notation. You see them as these ovals connected to their parent entity. So for our teacher entity, we're tracking name and contact. For the lecture entity, we've got date, length, and place. Each one of these ovals basically represents a column that we'd end up creating in a database table.
Okay, so we've got our nouns and their descriptors. Now let's look at how we actually connect them. This is where relationships come in.
Right, so if entities are nouns, then relationships are the verbs. They define how different entities interact with each other. If you have a business rule like, a teacher gives a lecture, that phrase right there directly translates into a relationship between the teacher and lecture entities. In Chen notation, these relationships get visualized using a diamond shape. You can see it here. The verb attends connects the student and lecture entities, while the verb gives connects teacher and lecture. It makes the interactions between all the pieces totally explicit.
Now, just knowing that a relationship exists isn't really enough, is it? We need to define the specific rules that govern that connection. And this is where cardinality and the different notation systems become absolutely critical.
Cardinality is where we translate those vague business rules into specific numbers. It answers questions like, for any one teacher, how many lectures can they give? And for any lecture, can it even exist without a teacher? These constraints are what make sure our data stays consistent and reliable.
So there are three main ratios you'll see all the time. 1-to-1, like one driver is assigned to one specific truck. 1-to-many, where one author can write many books. And many-to-many, which is like when one student can enroll in many courses and at the same time, one course can have many students.
Now, there are two primary ways you'll see these diagrams drawn. Chen notation, which we've been looking at, is really great for high-level conceptual modeling because all the different shapes are so descriptive. On the other hand, you have crow's foot notation. It's more compact, it's more technical, and that makes it the go-to choice when you're actually designing the database schema. It's just a lot closer to the final implementation.
Let's look at a direct comparison. On the left, in Chen notation, it just uses a 1 and an n to show a one-to-many relationship. Pretty simple. But now look at the crow's foot on the right. It's way more specific. That double line next to driver means one and only one driver is employed, and the crow's foot symbol next to journey means a driver can take many journeys. You see, it packs a lot more detail right into the symbols on the line.
Okay, this is basically your decoder ring for crow's foot. The symbol closest to the entity box, that represents the maximum number. The
The one further out is the minimum. A straight line or hash mark means 1. A circle means 0. And that three-pronged thing, well, that's the crow's foot, and it means many. So looking at the combinations, 2 hash marks means exactly 1. A circle and a hash is 0 or 1. A hash and a crow's foot means 1 or more. And finally, a circle and a crow's foot means 0 or more.
All right, let's put all these pieces together now. We're going to analyze a complete entity relationship diagram using that more technical crow's foot notation. Okay, let's break down this complete diagram for a library loan system. First things first, let's just identify the entities. They're in the rectangles, right? So we have reader, reservation, book, copy, and loan. These are the core objects our system needs to keep track of. Now, let's trace a couple of the relationships. We can see here that a reader can place a reservation. And over here, a book has 1 or more physical copies. Makes sense, but let's really focus on the cardinality between reader and loan. If you follow the line connecting them, the symbols tell us that a single reader can have 0 or more loans. And that makes sense, right? A brand new member might not have borrowed anything yet. Now let's look at it from the other direction. A loan must belong to exactly 1 reader. You can't just have a loan floating around in the system without a borrower. This precise notation is what models the critical business rules of the library.
So, we've covered the fundamental syntax. Now for a little thought experiment. Consider a really common scenario, a many-to-many relationship where many students can take many courses. Using the components we've just discussed, how would you model that accurately? Think about it. Is a direct connection between student and course enough? Or might you need another entity in the middle to capture all the details of that relationship?